So if you're looking for PHP information, you are at the right place. Just getting things sorted out right now. Alrighty. Hey, Bobby, go ahead and share your screen, and I'll toggle things on my end.
Okay.
Alrighty. Looks like we are just about ready to go here. All right, perfect. Okay. Oh, thanks everyone for your patience as we've started things off here. You are watching the September edition in 2025 of MergePHP, a collection of PHP user groups across North America, presenting in format online to making folks better at PHP and kind of level the community up. As you can see, fair number of user groups there, and we meet 6 p.m. Central, 4 p.m. Pacific, 7 p.m. Eastern, the second Thursday of the month. With any luck, my slides will advance. There we go. Obligatory logo slide of all of our various user groups here. And also, I'll keep this up for a few minutes, or let's say a minute or two. If you have not used JetBrains IDEs, I've daily driven IDEs ranging from PHP Storm to Goland and beyond for over a decade at this point. The tooling built into them is great and continues to get better. As part of MergePHP, we give away a license for 1 year of a JetBrains product. Could be PHP Storm, could be one of the other products as well. In order to enter for that, send an email to what's on your screen. Of course, this is only available for live stream viewers, but drop an email there, and first one in gets the license. All right, now that we've hung around there for a minute, let's go next. As noted here, we have a few different active versions of PHP. Make sure that you are running one that is at least in the security fixes mode. 8.4 is, of course, the latest release. 8.5 is coming later this year. 8.3 is currently in active support, and then you get into security fix versions. If your Linux distro backport security fixes, you may be okay with an older version, but when in doubt, upgrade to the latest version. PHP is great with fork compatibility, generally speaking, so don't have a lot to lose here. So we have a significant number of conferences on offer across the PHP community. A lot of them are not US based, but you've got BadCamp there. You have WordCamp in Montreal, which is not too far away. CakeFest is in Spain this year. Have WordCamp in Canada as well. And then Cilius, the e-commerce platform, has conference in France, and then there's the conference that I help run, Longhorn PHP, here in Austin, Texas. That is a Thursday through Saturday conference. Tickets are available. A schedule has been announced. I actually just got email early today confirming that we will have another platinum sponsor hopping on for our Friday after party. So excited to announce that. So, come for the learning, stay for the hallway track, show up for tutorials on Thursday, or just show up for Friday and Saturday for a number of talks and open spaces. I'm really looking forward to it. This is our 6th year. Going to be a good time, and early bird tickets are available. And if you're watching this and want to message me on socials for a $25 coupon between now and, say, let's call it Monday, feel free to DM me. I'll give you a coupon. Additionally, you've got International PHP Conference, actually right after Longhorn, then DrupalCon in Japan in November, Laravel Day in Italy, Better Code, SymphonyCon, and then you're getting into 2026 with Symphony Online, Dutch PHP Conference. For some reason, we don't have PHP UK on here, but PHP UK, I believe, is in February. And then DrupalCon in Chicago, Symphony Live again, and then PHP Tech in May in Chicago. We are reachable to some extent or other on socials, whether here on YouTube or on occasionally on Twitter, a lot more often on Mastodon via the PHPC .social server, and in the MergePHP channel on the PHPC Discord server. Looking forward to next month. There is I have a talk about MCP and Neo4j. And that should be a pretty decent talk to catch. The description of the talk is both here and on mergephp.com. Additionally, as part of Longhorn PHP, we will have lightning talks that Thursday evening, October 23rd, in person, and we'll be live streaming that out. TBD whether we try to do some sort of like streamed in thing where we actually pull lightning talks from online, but at least we'll have a live streamed event from the Longhorn PHP conference venue. Should be a whole lot of fun. If you have a talk idea, message us at one of the options on screen. We are looking pretty decent for the next couple of months in terms of talks scheduled. But we always love to hear from new folks in the community and existing folks in the community presenting on PHP-related topics. ping us here or go to that link and fill out that form, and we'll get you slotted in. With that, I'm going to hand it over to Bobby. Move this up here so that you can see the entire abstract of this talk. Just talking about the age-old debate of Vim versus Monolith versus microservices, and turns out there's a better tool for certain jobs. And my guess here is the answer is it depends, but I don't want to completely spoil the presentation. With that, I'm going to remember how to use the Restream UI and turn it over to Bobby.
Well, I think Ian just summarized the whole talk, so I think I'm all done, right? All right. Thanks everybody for coming out. I'm Bobby. I got intro slides. I guess I'll wait to introduce myself. The talk is called Monolith or Microservices and Why You're Wrong. Let's go. Let me get my presenter mode going. Is that working? There we go. All right. So I'm Bobby. I've been developing since I was a 12-year-old. Been pro for 10 plus years. I am an organizer of Boston PHP meetup group and which was one of the co-founding groups of MergePHP. I used to organize the Northeast PHP conference. We are not actively organizing it at the moment. But we do have plans to try to get it back up and running again. It's just, it might not happen for another year or so. So I don't want to like get anyone's hopes up. And in my free time, I like to support the open source community in any way whatever way I can. I love traveling, and then also basketball. And I was supposed to put gaming on here too, but if you can't tell from my shirt, I got a Portal shirt on. And so this is I just wanted to throw out this picture that here is a picture I took at Bryce Canyon. I like to do photography when I travel. I threw a couple quick pictures in here too. This was in Iceland, some turf houses on the water, and then this was Switzerland, which I thought was a view from one of the places we stayed, but after I put it in the slide, I realized there's like a reflection in it, which means I took this from one of the gondolas, like going up the mountain. So the Seilbahn, they call it. But yeah, any chance I get to go go hiking in a place that looks this ridiculous, I'm all for it. So what you guys all are here for, we want to talk about microservices and whether or not it makes sense for you to migrate, and the answer is no. So thanks for coming to my TED Talk, and no questions, please. Let me get a quick drink. Okay, but for real though, the talk's broken up into 6 parts. Here's the plumbing of the talk, if you will. They're self-explanatory. The thing I want to point out is the third section is going to be where probably the most meaty part of the talk is. But everything else, I'm just trying to kind of touch upon some things and move on. I don't want to keep you guys here too long. So section 1, we're going to give a couple quick definitions. What is monolithic development? It's kind of the most simply, it's kind of the default way that any project tends to start. It's usually one single application. It's self-contained, and it's usually a monorepo, just one code base, and usually there'll be like one data store, and over time, as a team grows around the monolith, if it's a company or like a large project, over time sometimes it'll be more than just a monorepo. There's exceptions or whatever, but not important right now. But another thing that happens over time is Conway's law will cause some tight coupling. I'll just read it quickly. I don't like reading off of slides directly, but I'm just gonna since it's a famous quote, I'm just gonna read it real quick. Any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So what happens is you create the initial application without the structure of an organization in mind, and over time that structure, the communication structure, just kind of causes the over time, as the system, as the code base is growing and the team is growing, it has a big impact on it, which makes it grow in ways that maybe weren't expected in the beginning. You end up with tight coupling, and even if you tried to avoid it initially, over time it becomes kind of impossible to avoid. Not impossible, but that's the natural way it'll go if you don't do anything about it. Can I? What did I click on something? Hang on. There we go. It's working again. So one of the solutions for this is something that was proposed. I think it was proposed in 2014, but it may have been like 2010, and then it got like popularized in 2014, something like that. But microservices was kind of like an evolution of service-oriented art. If you guys remember, service-oriented architecture was like the big. If you're old like me, that was the buzzword. That was the bigger buzzword back in the early, like 2010, early 2000s, and microservices kind of took over that. It was kind of an evolution of it. And does that show up? Can you guys see a pop-up in the corner here? I just want to make sure I don't have things popping up on the screen here. Oh, that's why I was so confused before. Cool. Sorry about that. A little technical confusion on my part, but I got it figured out. So this is microservices. Basically the idea is you break up your application into several smaller applications, which tends to over time be a lot of smaller applications. Each one has a single purpose, and they can be independently deployed. Each service can be independently deployed, and they have their own. They have their own code base that's owned by a particular, it lends itself to having smaller autonomous teams that can own each service and develop kind of freely without having to make sure they can develop and deploy their application without having to test it with all the other microservices being deployed at the same time. This also, and it's mentioned on here. This is like the technical definition, like the official-ish set of characteristics of microservices architecture. And then I threw in a couple extra. Microservices are, if done correctly, are loosely coupled. They will use multiple code bases. It's recommended you have a separate code repository for every microservice. There's other ways to do it, but if you're going to do it a different way, you got to be careful that you're not overcomplicating things. It creates problems if you one service is two code bases and one service is one, and yeah, I'm going on too long about it, but yeah, try to keep it one-to-one. The service that you break off of the monolith will work within a bounded context, which is a term from design-driven development. That's a whole separate topic that's beyond the scope of this presentation, but I will give a reference to a recommended book to learn about that if you want to, if you need to want to learn more about that. Let me go. I clicked on the thing again. Here we go. Second section, pros and cons. So for monolithic development, it tends to have the So the pros of the monolith development is you deploy everything all at once. So what I call the latest version here is the last time you deployed, everything should just work because you had your CI/CD suite just test everything all at once. And then you just make sure it's all working. You deploy it all. And then until the next time you deploy something, you know everything's working. There's only one CI/CD suite you have to worry about. You don't have to worry about multiple, which is a little complexity that microservices will add. Deployability is easier, which is kind of related to the last bullet point. What did I put? Data throughput. And when data throughput tends to be quicker and clearer in the sense that you have like one single source of truth for data, which may not still be the case in a microservices world. But like something gets updated, like a customer data gets updated and it's immediately available to other, like what would be services to other parts of the application. And performance tends to be better in the sense that is like if the code is written the same way in the monolith and then in a microservice, the performance will be a little bit better in the monolithic version because of the lack of the extra overhead of things like load balancing and other little small things that are required to properly handle a microservices environment. The cons of monolithic development being that your app is a single point of failure. If your app goes down, everything is down because you only have one app. Also, maintenance is a little more of a pain because if you want to bring down, let's say you have like an order processing module or something, you can't just bring that down without affecting the rest of the site because it's all one. You might be able to do it by some trickery, like make a change to the code that disables something and then immediately change it back. It's way more complicated to do that. In a microservice, you can just turn it off, turn it back on. And then the lack of scalability is usually the reason that people want to move to a microservices architecture. What I mean by inflexible is that is the same thing I was saying before about like one part of the application is interconnected to all the others, so you can't just bring one down, or you can't scale one part. You can't say like order processing, for example, is getting bogged down. We need like 5 instances of it. Well, now you have to have 5 instances of the entire application, which if you're getting to the point where you're considering microservices is probably a big application. So it's an inefficient way to scale if you want to do like containerization or type methods of scaling your ability to handle throughput, that kind of thing. Monoliths tend to be tightly coupled for reasons we talked about already about Conway's law and just the fact that you can access other parts of the code base. Usually in a monolith you can access other parts of the application very easily, too easily. And over time the things like the CI/CD suite or can grow to the point where you're running tests for everything in the entire company instead of just your part of the application that you care about. So you're spending a lot of time waiting for checks to go through, pipelines to run, that kind of thing, where it really doesn't need to take that long because of your concerns aren't as wide as what the CI/CD is running. So it slows. I skipped over velocity, but that'll slow your deployment, and then the tightly coupled nature of things combined with the deployment and some other stuff will slow down just the technical debt that you get in monolithic development without constantly trying to manage it will slow down development and decrease velocity. So good things about microservices is it's more scalable. for the opposite reasons that we just discussed, then you can maintain in a modular fashion in the sense that if you need to, like I said before, if you need to bring something down to do an update or something, you can do that without bringing down all of the application. You're just bringing down one service. You can have these full team ownership over a service, which makes changing things a lot easier. You don't have to coordinate with other teams to get stuff changed, and or people aren't changing your stuff without telling you about it. You'll have smaller. It promotes smaller. It promotes it. It encourages, works better with smaller autonomous teams that have the ability. They have more freedom to go do stuff more quickly and create value faster. And excuse me. And it encourages, and because of the fact that the systems are separate from each other, the tight coupling tends to be harder to. It has a harder time creeping into the system. The cons are there's a lot more complexity in a microservices environment, which is why I'm recommending that you wait as long as you can. I'll talk a little more specifically about when to make the change later. But yeah, complexity because of now if you once you move to microservices, you have all these other applications that can't see each other. So you need to have some kind of like an observability platform. You have to have a way to find all of the services. You need a way for them to speak to each other. You may have asynchronous communication tends to be recommended when you're communicating between services. So you're going to want like a event bus or an event management system or like a messaging queue system or something like that to communicate between the services without calling them directly. Version hell is like a common complaint of like if you change an API for something and you don't do it in a way that if you don't do it in like a best practice kind of way, then you can break your APIs for all of your consuming services, and you're not testing those services when you deploy. So you need to be aware of like these type of techniques to make sure that it's just like an added piece of complexity on top of what you would be doing in a monolith. And what did I say? APIs, interfaces. I think that was supposed to be indented. And then the data consistency tends to be a little harder to achieve. There's a concept that you can read about. You can Google called eventual consistency. It's not as immediate as the type of consistency you get in a monolith. So you would so it's a little more complicated. You have to be aware that like data might not be available right away when it gets updated, and there's some various stuff you can do to like handle that. I keep clicking on the wrong window, so it makes my keyboard stop working. Oh yeah, by the way, there's some more cons. They didn't all fit on one slide. So overhead is another thing. You have runtime overhead, and you have development overhead, and you have was there a third type? I think there was a third type. I don't know. It's probably covered in here though. But yeah, you have network latency tends to be more. You got like if you have a load balancer that decides which service you're going to hit when you want to call a particular service, and say it has 5 instances running, you may have like a load balancer layer that like decides which one to hit, and that extra ping or that extra layer just adds a little bit of overhead to every call. And if you're doing any kind of like data serialization or deserialization to communicate between the services, or to create messages in the queue or whatever it is you're doing, that can slow things down a bit. So there's also like maintenance overhead in terms of managing like the third-party tools that you're gonna like having like decoupled databases is not a new tool because you already have a database with a monolith, but managing decoupled databases adds a little bit more complexity that you didn't have with monolithic development, where everything was hitting one or maybe two data sources. And then there's more infra costs. And I'll just kind of let you look at these. There's a lot of, like I was saying, third-party tools you're going to want to add, and to handle all these different distributed things that you didn't have to worry about with the monolith. So section 3 is the pitfalls. This is going to be the biggest part, but I'm going to try to go through it reasonably quickly. You want to avoid running into problems where the complexity of the system is making troubleshooting, fixing issues, or just development in general take way longer because of, like, if you don't follow best practices when you move to microservices. I was while I was researching for this to write this talk, a couple times it came up that there's experts that feel that companies say they are using a microservices architecture, and like 90% of the time, or I don't remember the number, but like 90%, 95% of the time, they are not using a true microservices architecture because they don't implement all the things that make it like a working microservice architecture. So one of the first and biggest pitfalls that people run into, they assume microservices are always better than monolith, which is absolutely not true. If you've seen Fight Club, the first rule of Fight Club is don't tell anyone about Fight Club. First rule of microservices, don't use microservices. Second rule of microservices, do not use microservices. Eventually, you're going to use it anyway, probably, but resist it as long as you can. You want to avoid. So when you break things off into multiple services, it's easier to maintain decoupled services, but there are ways that they can still get coupled, and you want to be aware of those. And just like when you're designing the system, you want to make sure that your team is aware of how the things, like what one service represents in terms of the bounded context that it represents, and like what you need to not do to make sure that it stays appropriate to that bounded context, and that you're not going off and doing more things that should be in a separate service, or you're not turning your services into small monoliths, that kind of thing. That's the big no, is not creating a distributed monolith. A couple of services. And yeah, another thing that I mentioned the data stores because a lot of times people think decoupling is just decoupling code, but you need to decouple your data as well, and not doing so will cause a lot of problems in a microservices architecture. And then the next pitfall is what I just said, actually. Sharing data stores across services. You don't want to share it. You don't want multiple services hitting the same data store. If it's hitting it in a read-only sense, maybe, but even then I would try to avoid it, because if another service that's not responsible for your data tries to access your data directly, they may not have the same context you had while creating the data and may not use it correctly. So it's easier to put guardrails around that data, or filters or whatever it is that you want to if you need to massage the data so it makes more sense as a business object or whatever. It makes more sense. It's better. It's usually better to just go through the service to get to the data rather than hitting another service's database directly. So another pitfall is wrong sized microservices. If they're too small, they're going to be too chatty. If they're too big, they're not chatty enough. And then what's the point of even making services if they're not talking to each other? So yeah, the exact like I mentioned before, the bounded context that you want the service to represent should be figured out. You figure that out using design-driven development principles. And is this where I include? There we go. There's the book, domain-driven. Did I say domain-driven design? What did I say? Design-driven? Domain-driven design, DDD. This book by Eric Evans is recommended by experts more well-known than me. And it's a very I haven't read it myself yet, but I'm going to eventually. And so I just wanted to mention that because I haven't read it myself, but like people more well-known than me are recommending it. So if you want to get more in depth on DDD, then that's a good place to do it. Starting from scratch is another big pitfall that a lot of people walk into, because if you have an existing system, you're dealing with legacy code. It's very tempting to want to just start from scratch and just rebuild everything, but that's almost never a good idea. And turns out greenfield in practice, greenfield development is actually harder because you're designing in a vacuum. You don't have working examples to base your design off of. In brownfield, you have existing code that can inform your design. You have people who know the system that you can discuss with. The system already works. A lot of the things that you didn't need when you initially designed have been either removed, or they're just, you can tell they're not being used, or it saves a lot of time designing for things that you don't need. And it also prevents you from going off or just not knowing when you're done, because you don't know if you've thought of everything. You basically have a system working right there. Everything is there. Everything is there to be found. It just might be in a legacy format that might be scary to work with or whatever, but it still tends to be better. And it also gives you a baseline to compare against. So if you have an existing app that's running, you can have metrics that are being collected that tell you, like, I don't know, what's your revenue, or you can get performance data, tracing, whatever, that just tells you how the system's running. And then whatever's important to your organization. And then as you're moving to microservices, you can keep an eye on those things and make sure that they're not like tanking or whatever. Another pitfall is when you're dealing with cross-cutting concerns, or like what do you call it? Interfacing with infrastructure tools. Things that a lot of your services are going to use, like, for example, like database, like having a library that lets you access a database. You just want to make sure that those things aren't done in a way that over time is becoming coupled, because that's gonna break the decoupled nature of the microservices architecture, and that it moves you closer to a distributed monolith, which again is the big no-no that you want to avoid. So for cross-cutting concerns, you want to have third-party tools whenever possible. Most things, because those type of things, so if you don't know what cross-cutting concerns means, it's like things like logging, tracing, like I would consider, I mean, it's kind of infra kind of, I guess if it's cross-cutting, database access. There's a bunch of things that like every application, not every application, but most applications will need, like for the like most of them will use like 80% of these things. And the way that they're accessed can be controlled better and done in a more decoupled way if you're using wrappers, libraries to access them. And and third-party tools usually have a lot of the problems solved because it's not your business it's not your business logic, which is what you're there to solve. It's sending messages to a queue or managing a Kafka topic or whatever. You can just have your own, if you just have, you create your own shared libraries that the services can use to interact with these things, and you can put your own guardrails on it. If there's like a library that you want to, actually that's not bad. Library is not a good example. If there's like a certain type of query that you don't want people to run because historically it like breaks your system, then you can like put warnings or like, or block it using the libraries. It gives you more control over how you access these things. And if you change a like a library that you want to use to access the like an ODBC driver or something like that, you can do that in the wrapper and not have to do it for every single microservice. Synchronous service-to-service communication is one of those. It's one of those ones where I'm a little skeptical that it always needs to be asynchronous all the time, but I would definitely like make an effort to limit, if not eliminate, synchronous communication between services, because if you have one service, if you have a service A that's calling service B and it has to wait for a response and it can't continue without getting a response from B, is it really decoupled? There may be cases where the service that's being called, the result isn't super important. It's just like maybe an added benefit to the request, but it's not totally required. And maybe the thing's small enough that it's not a big deal if it's synchronous. But I don't think it's you want to avoid it whenever possible. I think that's what seems to be recommended anyway by the experts. Breaking changes to contracts. This applies to a lot more things. I think when I was researching this, this was in the context of event schemas, or like changes to events in general. But it also applies to APIs. It applies to data schemas. It applies to messaging. Just like any way that there's a communication between the services. Make sure you're using things like semantic versioning, open close principle. You don't want to change something that's going to break. You don't want to like remove. Let's say you remove a field from an API. Then everything that's calling it that doesn't know you removed the field is still going to be sending it, and they're all going to fail. And if you use the open close principle, you can avoid these kind of things. So that goes into why you should invest in, if you're moving to microservices, you should invest in developer education to make sure that everyone's on the same page, because there's going to be things like you have a lot of smart developers in your organization, but there's going to be bits and pieces that each developer doesn't know, right? And everyone comes from different backgrounds. You can't just assume that everybody knows everything. So that's going to be an important thing. I'm going to mention that later too, but that's a preview of why anyway. Not automating deployment. If you don't have automated CI/CD or something similar, like before you start moving to microservices, it's going to be a huge problem. That's definitely something you want to get under control before you start. So the next section is whether or not you should migrate, and I'm actually going to answer it this time. My first answer, though, I said the first time I said no as a joke, but it's kind of not a joke. Make sure the costs of migrating to microservices are like far greater than most people realize when they start this journey. I tried to break it up I tried to get as much as I could of like what the initial investments you have to think about are and what are the ongoing costs that you're going to have to pay for, like, to maintain everything once you've moved or started to migrate. So first is going to be a whole planning phase, and that's going to take up a lot of your engineers' time because it's a lot more complex than people realize. So you're gonna like I just threw a couple examples of what you need to plan on here, but it's way more in depth than this. But like your whole migration strategy and like what services I overuse that word too much. What do you call it? Third-party tools and things that you're going to use. You're gonna have to probably use things that you weren't using in the monolith world. You're gonna want to get those things configured, make sure they're working before you start throwing new services at them. And there's a lot more we could talk about that's beyond the scope of this. Making sure you know who's going to own each service. Don't start breaking off services and not have an owner, not have like a plan of who's going to own it, that kind of thing. It is possible to start breaking off services like gradually, iteratively, one at a time, but you still want to know who's going to own the thing ahead of time. And like, are you going to need to pay more money for servers and storage? And are you going to need to get more headcount? Spoiler alert, you probably are. And actually, I want to say you absolutely 100% are, but I don't know for sure if there's some weird exceptions. I'm pretty sure in 98% of cases, it's probably going to cost. You're going to have to, your infra costs are going to go way up. So you're also going to want to invest in developer education. Like I was saying before, there's little gaps that everybody's going to have little gaps here and there, and maybe together everyone knows like everything's got, maybe all of the topics are covered when everyone is together in a group. But if one person is off developing something, and between them and the person reviewing their code, there's like a bunch of gaps that they share, those things are going to creep into the system, and it's going to cause problems. You're going to have like broken contracts and stuff like that. You're going to lose your loose coupling, that kind of stuff. So and then you're going to want to make sure the automation, like we were talking before, you're going to want to make sure your automation is all working and like comprehensive enough so that your manual efforts to do these things aren't going to skyrocket once you start creating the services. And like I said before about when you want to interface with infra tools or any cross-cutting concerns that don't necessarily involve the tools but need to be done in a consistent way, you want to consider creating shared libraries, composable libraries that the services can pull in and use for their purposes. So the way that some organizations are going to, when they move to microservices architecture, they try to do it all at once. I've heard it referred to as the Big Bang technique or whatever. That tends to fail. It's not a recommended way to do it. I think there's some cases where it's been done and it worked okay. But it's not recommended. You want to use something like the strangler fig pattern, which all it really is you start off with a monolith. Like on the bottom left, I don't know if I have the ability to point to it. Let me check 1 second. This one, I can't tell if it's showing up on the slide, but so in the bottom left corner, you got the monolith, and above the monolith, you have nothing. So that's where you're starting. You're starting off with a monolith and no microservices. And then the next one is monolith, a little bit smaller. You got a new service and a service that was broken off from the monolith in what we call the strangler application, which is just your microservices part of your architecture. You can create the microservices, gradually decouple them from the monolith, and just have that grow and grow. And eventually the monolith is going to shrink and shrink. Eventually you just want to kill off the monolith, if possible. So in some cases you might not be able to fully kill it off, but sometimes there's cases where you kill off 90% of it, and the remaining 10% isn't stuff that anyone really touches anyway. And sometimes it makes sense to just leave that. Ideally you want it all moved over if you're moving to microservices. Let me switch back. Okay. So alternatives so we talked about monolithic development and microservices development. The alternatives, just to think about, I'm not recommending either one per se. One of them I'm definitely not recommending, which is the distributed monolith. That's the one that keeps coming up if you're reading about microservices, migrating to microservices. This is the thing you want to avoid, is having a bunch of putting in all the effort to create all these microservices and create like what do you call it? An infrastructure around them so that you can use them. You put in all this effort, you change all this code, but they are still tightly coupled together, and you end up with the worst of both worlds. Instead of getting the benefits of the scalability, you still can't scale, because every time you make a change, you still can't scale efficiently, because every time you make a change to one service, now you have to test all of them together because of the tight coupling. You might have to make changes to 2 or 3 services at the same time, so you're not breaking anything. Distributed monolith is bad. Don't do it. And then I just wanted to throw out something that our good pal DHH. For those of you who don't know DHH, his name's David Hennemeyer Hansen. He's one of the founders of 37 Signals, and he is, how do you say, somewhat opinionated about software-related things. Their company moved to microservices, I don't know, 10 maybe years ago, and they eventually moved back. And he talks about this concept called the majestic monolith, but also a few years ago he suggested the idea of the pattern called the citadel, which is one single monolith for the majority of your stuff, and then what he calls auxiliary outposts apps, which is other monoliths, I guess, or they could be microservices, but just for the really, really specific things. But most of your application will stay in the monolith, so you get the benefits of having a monolithic system. And I don't know, it's less complex, but you still end up with more. I don't know. You still end up with more complexity. So the reason I mention it because it seems like a cool idea. There's not a lot of examples of it. There's some examples of it working, but those examples tend to be companies that are either owned by or like tightly connected to 37 Signals. So it's something to keep in mind for the future. I wouldn't recommend jumping into it now. This is what I imagine it looks like. You have this big monolith in the middle, and then around the outside, you can see all these little towers on the outside that are the outposts, and then like the infrastructure to communicate to all those towers, or to send event data or whatever it is to all those towers, is like all these little bridges and stuff going across. And then the spaceships are just cool. So I don't know what they represent. So here's the text version of what I was just saying. Yeah, it kind of resembles service-oriented architecture a little bit more so than microservice, but you still want to keep in mind the best practices for microservices and like the pitfalls, because a lot of those will still apply, and you don't want to get caught by those. So just something to keep in mind, food for thought. So in summary, monolithic is usually better. If you're not sure, stick with monolith. Only migrate if you fully understand the costs. If the pain of not being in a microservices architecture outweighs those costs, which for most companies and most projects, it doesn't. So you want to really make sure that your velocity or your lack of scalability or whatever it is causing problems to the point where it makes sense to invest all of this time and money into this migration. And then make sure you have a fully complete plan before you start making those investments. So I guess the complete plan will involve a little bit of it. So invest in the making sure you have the complete plan before you invest in all these other things. And then maybe the Citadel will start to be, maybe that'll be the most popular one. We don't know yet. Time will tell. But if you choose to migrate, the single response. So I don't think I mentioned solid at all, but solid object-oriented development principles apply in a lot of ways to this architecture. They don't only apply to, I mean, they're meant for object-oriented classes and stuff, but they also apply to architecture in the sense that single responsibility makes sure that your like your services are encapsulated and that they're not tightly coupled with other services that they aren't meant to touch. And then open closed principle will help make sure you're not breaking APIs or whatever your contracts are. In the Strangler Fig pattern, not part of solid, but this is why I highlighted the S and the O in those first two, because those are part of the solid principles. Strangler Fig pattern is the way to migrate. It's the recommended way to do it. Not the only way to do it, but it's the recommended way. And then keep in mind the list of pitfalls that I mentioned. You can search for pitfalls of microservices, migrating to microservices, and you probably find a list very similar to the list that I gave you guys today. But that's it. You want to keep those things in mind as you're migrating, and you want to make sure that your developers know about these things so that they can keep in mind and do something about them before they get out of control if you do get hit by those. So thanks everyone for your time and for listening. If you have any questions, feel free to throw them in the chat. I got to make sure I could see the chat. I could before, but I don't know what I did. Hold on. I got too many windows still open, even though I closed all the windows before this, and somehow I still have too many open. Which make sure I'm reading them in the right order here. Cost overhead to maintain the microservices. Yeah, feel free to throw if you got questions, feel free to throw them in the chat, or you can feel free to send me an email or contact me. However, I got a few ways to contact me on this last slide here. Ian thinks he's used the Citadel pattern before. I think so. The Citadel pattern, I think, is kind of what you're doing in the meantime as you start migrating to microservices. But you generally don't want to, you don't want to hang out in that middle scenario for too long. You want to at least have a plan to finish the migration and not just kind of to let it sit unfinished, because you won't get the full benefits of microservices until things are fully migrated over.
So that's kind of a different perspective that I've actually seen when working on some of these things, where it's like, okay, there's a certain piece, there's a certain process that has nice kind of cleanly defined interfaces to the entire rest of the application. And it's like, okay, there are very few points of contact. This is a clean API. We don't need like the entirety of the rest of the app. So this can be developed on its own and then just kind of stay there. and I've got various examples of that, like where my day job is right now. We have a monorepo. However, there are various workflows within that monorepo that that are self-contained, don't require building the entire project, and like there are code paths that are just kind of over in a corner, and just kind of don't interact with the major code base, which is a monolith. And it's not like we're trying to refactor everything toward microservices, but it's like you take the single responsibility principle or that sort of thing wins when you can get them, just like you wouldn't want to have 15 parameters to a function call if you can avoid it. And whether it's 15 explicit parameters or you're passing a massive state object around that basically does the same thing.
Prop drilling. Prop drilling.
Yeah, maybe.
Yeah.
But if you have clean points of articulation in the application where it's like, well, this can be off at quarter, and as you mentioned in the presentation earlier, having that piece of the application scales very, very, very differently than everything else, then you kind of take those wins when you can, while potentially having the rest of the API be over function calls rather than, say, like HTTP or something like that. So like I've seen that done to some level of success elsewhere, just didn't necessarily have a name for that pattern.
Yeah, so doing that inside of a monolith can work. It's just if your team is growing and the newer people on the team might not fully understand how to keep those things separated, and you may end up seeing more coupled, like direct calls and stuff like creeping in that didn't need to be there. So just a thing to keep an eye out for if you choose to do it that way.
Sure. In your experience, I'm guessing that you have seen cases in your work where there has been a migration from a monolith to microservices or potentially back. When those have been successful, was there kind of a pattern in terms of either team size or code base size, where it's like, yeah, this actually made sense to make the jump, and it actually fully happened?
Are you saying like what's the team size? Is that what you're asking?
Yeah, specifically for, like, I'm guessing you've seen this in your experience one way or the other of places that you've worked at doing a migration one way or the other.
The biggest example I have, like the most thorough example of doing this was at an organization that had over 200 engineers. It was over 200 engineers working on the monolith, and there had already been attempts to create new services and stuff outside of the monolith, and there was I don't know, several hundred, I think, other engineers that weren't even touching the monolith. So it was like a total team of, I want to say 500, maybe more, but it was a ridiculously large developer organization, and the actual migration to microservices was over like several years, and I was gone by the time they actually finished. But we saw really impressive progress during that time. So if you put guardrails in place and you try to follow the best practices the best you can, it'll almost kind of like slowly start to like, I don't know, it's like a feedback loop that kind of feeds itself, and it starts to like the progress tends to like kind of get better over time.
Sure.
Until you hit a point where there's like those last few things that like nobody cares about, that it's like not even worth migrating, and then it starts to taper off at that point. But
sure. And like that's useful context to have, because when folks are like, I should do microservices, like, well, how big is your team? 5 people. It's like, no, you should not.
Yeah, I thought I was in my
you had
notes,
mentioned that earlier.
I have like some data about like what team sizes where you should start considering, but like I got such different values from different places. But it seems like if you're like if you have less than like 10 developers, it's probably not even worth. There's very few cases where it would be worth it to migrate.
Yeah, particularly since for any given microservice, what you don't want is you build out a service that's then abandonware, and then it winds up like
Yep.
5 versions of the runtime out of date, and then nobody wants to touch it, at which point it's like burn the thing down and start over.
Yeah.
Okay.
Yeah, that's another thing I forgot to. I mentioned maintenance in my the cons of switching to microservices, but like updating dependencies like Linux operating system version or like PHP version like can be really tricky to do when you have like 200 microservices that all use different instances of it, and they're all on different versions. You know,
you have to basically have like platform engineering or SRE or whatever just to make sure that everything stays in lockstep. So you don't have stuff that, you know, the one service over in the corner that got left behind and nobody feels like it's valuable enough to bump it up to the current version.
Yeah.
Yeah, makes sense.
And then one little thing I forgot to mention is when you're using the strangler fig pattern, you may want to only divert like small percentages of your traffic to using the new microservice that you broke off, and don't remove the code from the monolith right away and just like test it. And if it's a critical thing, you don't want to like bring down, like if it's order processing, you don't want to bring down order processing for everyone because you migrated everything over to a microservice and now like it broke for some reason. And
I guess,
you just divert, like keep the original stuff in the monolith while you slowly increase the amount of traffic that you're sending to the microservice, and then eventually when it's like 100%, then you can remove the code.
yeah, I guess the tricky bit there, of course, is since microservices are supposed to own their own data stores, how you actually manage that so that you're dealing with consistent state. And you know how to route the traffic of like, okay, I wrote to this thing, now I need to read back from it. And of course, it may be a little bit easier. Like, okay, we're going to build this, you know, completely compatible API that actually does write to the old monolith data store, and then, you know, first strangler fig the API and then swap out the data model later. But also that means like if you stop halfway through, you have a distributed monolith, and it's like all the bad things about of both approaches.
Yeah. Yeah, that's kind of like what you want in the back of your mind at all times when you're doing the migration, is like don't turn it into a distributed monolith. That's like probably the number one thing. That's the thing that comes up. Everyone who I've seen talk about this, that they all mention that. They all are like, make sure you don't accidentally create a distributed monolith, because that's the worst of both worlds.
Cool. Just double checking chat to make sure that there are no further questions. I think Logan had one about use temporal.
I have not.
All right. I think that is it. Thank you so much for presenting, and thanks to everyone who has tuned in for this month's edition of MergePHP. We will see you the second Thursday of October next, and then later on in the month on October 23rd for a special edition live from Longhorn PHP. Thanks, and we'll see